Okay, so the next part, we wanted to kind of start to give it a little bit more kind of exposure to a new Cumulocity feature called device parameters. So for those that don't know about what this is, this session is for you. So it's basically a new kind of device management functionality of Cumulocity, which allows you to kind of edit additional parameters on the device. So what those kind of like the doing action of those parameters is really up to you to define, because you can imagine that, you know, it might be writing to file, it might be sending some API calls. The integration of what those parameters actually do really depends on you. But what you get with this and compared to like configuration management, because there's from a functional aspect, it's very similar. But the main advantage is with the parameters, you actually get a pre-built UI for free. So that means you can actually set different individual kind of parameter values. It's all JSON schema driven. So it allows you to be a little bit more freely to define your configuration on the device, whether this is targeted for a customer user interface, that you had customers saying, hey, here's the values that we allow you to kind of configure, to your liking, or you just want to kind of standardize something and reduce the room for human error by using the schema to define what values are accepted, et cetera, et cetera. So this feature is still, it's not enabled by default on all the tenants. And I believe on like Cumulocity.com, it's still in the process of being rolled out. So if you are interested in trying this out, I think it is available in EU latest, but I think in other environments, you can then reach out to the support to create a Cumulocity ops ticket or like support ticket to then request it to be enabled. So
is it part of the ch demo container?
No, but you can kind of install it. So it's actually published part of our community repositories. So that's exactly what it'll be showing in our setup.
Okay.
So you can kind of like, so let's actually have a look what's going on. So I'll show you the feature first, and then I'll kind of peel back, open up the hood and going, what's happening actually in the background? How's this actually working? What is the plugin driving this? What's the kind of interface point that I can play around with? So here I have a TEDge demo container running the 2.0.1. So I should be able to just confirm TEDge, yes, 2.0.1, cool. And you'll now see, because I have enabled, there's a few prerequisites. So from the Cumulocity side, you need to have the device parameter microservice, which then provides this kind of backend functionality, and also the plugin, which shows the UI element, but also the digital twin manager application. So the digital twin manager is used basically to provide API and a nice UI to allow you to define your JSON schemas, which are driving what will be presented for the parameters. So for example, I have parameter X that has, 3 different parameters that I can control from that. You can add descriptions to them and build your JSON schema from a comfortable UI. So once you have those 2 requirements fulfilled, then on the device, so I'm in the device management application. I've already navigated to my device, and you'll see that we have a new tab. So it's called Parameters. I've pre-configured, so for my device, I've installed the plugin from the FinEdge side to kind of then use this new Cumulocity functionality. And I've already defined 3 of my custom definitions. So I believe they're called asset definitions. Correct me, or property definitions. I'll check in the UI soon. So for one kind of like good use case for this. So with flows, so the big feature that we released in 2.0.0, which allows you to kind of create your own custom mapping rules, logic to then create alarms and thresholds and all this kind of stuff. All of them are actually configurable. So you can actually expose the parameters.toml, so params.toml file, to then even allow users to configure specific elements of your flows. So we figured, well, wouldn't that actually be a great fit for showcasing what can you actually control with the Cumulocity parameters feature? So this works really, really nicely. So I have actually demoed this, I think, in a few kind of like indirectly in the past, but I'll give a full demo. So here I've already defined on my device, I have a special local analytics flow, which then it is running, where I just want to kind of be alerted when my certificate is about to expire. I want to get 2 alarms from this. I actually want to say a warning when, you know, it's like 90 days out, and then I want a critical alarm or a major alarm when it's like 30 days out, because I really need to react now, because maybe some kind of like auto renewal logic didn't work for whatever reason. I can then, you know, debug what's happening on the device and then fix it before the certificate expires. So the device certificate, because as most know, if the device certificate expires, you cannot connect to Cumulocity anymore, because all of the PKI trust is established based on, you know, valid from, valid until dates on certificates. So they always have a validity period that must be adhered to. So here for the certificate alert, so for this local analytics kind of checker, there are a few kind of parameters that I wanted to make user defined. Because you can imagine that, you know, for me, 90 days is enough time, or 30 days, but for someone else, you might have processes, or you might need to do this on site or whatever. You maybe want to configure what the thresholds are. So for this, I've already created the digital twin manager asset definition, which defines my data model. So that defines that this key has then these properties available then for the user. So I've defined that the user is actually allowed to edit these values. So you can actually even control whether they're editable or not, because you might want to have some read-only fields or whatever, or read-only, so people can just see what the values are, but you don't want them to change it. That is possible. But for here, I want to kind of be able to go, you know, customize this device to your liking. So if I go, well, I actually want to change the threshold warning to 390 days, I can just save it. That sends an operation down to the device. The ThinEdge plugin then knows what to do with that, applies it to the associated flows. So writes the params.toml file with the new value, and then it's active. And because flows from day one have actually been designed to be hot reloaded when anything changes, so whether it's the JavaScript, TOML files, or whatever, that will be hot reloaded. So no service restarts are required. So if I go to my alarms now, I have now a warning because my certificates are only issued for 1 year. I'm over a year, so I've, you know, crossed the threshold, and I now have my warning alarm. So it means that previously, if I've had to do this, like to make that parameters configurable from the flows perspective, I probably would have done, like, you could do configuration file management, but then you're a little bit in this, you have to kind of get the configuration file from the device. You might be able to edit it conveniently, but then you need to redeploy it to the device. So like the workflow is a little bit clunky, or a little bit slower, and you lack a little bit more of being able to really formally describe your data model and even have a rich kind of user interface by default. So a lot of users, especially like more business users or non-technical users, if you present a file to them, they'll be going, what do I do with this? Regardless of how much auto completion you can have available there, having a richer kind of UI element like here is a lot more convenient. So I can have like checkboxes, etc., to then control other aspects. So there's a lot of basically anything you can do in a schema. So if you can have an enum, I think it'll be translated to a drop-down list. You can have regex validation, etc., etc. About it. So I'll just try to read the questions in it. Yeah, so I'll go into how that actually works shortly. So these definitions, so I'll just show how that kind of, so if I were to navigate to the digital twin manager here, So this is what I have opened here. This is actually the definition on the cloud side, so it knows how to build this UI. And it knows how to offer these kind of options and display these options within the UI. So I can define, so this could also be like a simple object if you want to do some, just key value stuff. But here, because for a flow, we've tried to define, well, for each flow, if it defines parameters, then you can also then define what this kind of like, what should be then uploaded to the platform to then provide these options. So here I have disable alarms. I can then expand that, and this is a Boolean type, or if you're in a little bit here, a text. You can also add validation rules, minimum length, maximum length, regex, etc. And then you can have a little bit of preview. So this is actually the data model, which is currently then shown on your, so like the output of, because in the end, these parameters are actually written on the device manage object associated to the actual, where the parameters are coming from. So if I looked on the manage object, then I would see basically this data structure with whatever values the device is pushing to saying, yes, this is my current state. And then you can control the changes via the operations. So how does this actually work? So I find, so on the device, if we just go here, so we have some plugin installed. So we have a TEDge parameter plugin. So this is only one example. So you can diverge from how to do this or whatever, but I think it's a powerful example how you can use the core thin-edge functionality to actually build your own abstraction system. So this is what this plugin's doing. So when kind of designing it, we thought, well, do I either want to create one plugin per type? And that might get a little bit harder to maintain because then you have, if I have, I know, a log search definition, like do I need to then create a separate plugin just to modify those values? Or do I want to kind of orientate it on like technology type? Or do I want to create my own plugin system? So when I say the plugin system, good example for that is if you followed our like TEDge configuration plugins, that we have like a file plugin. So it's more like based on the type of file it is. So you can either use our built-in file plugin, or if you have like some magic API or monet, whatever type, that you can then define what the handling is there. So with this plugin for the TEDge parameters plugin, it tries to reuse some of those concepts. So that I don't actually need to, I can use this TEDge parameter plugin to actually facilitate other parameter plugins. And this is all using just out-of-the-box thin-edge functionality, but it shows that you can kind of be really fancy and create your own abstractions using the built-in thin-edge stuff like workflows, etc. So what do I mean by this? Because it sounds very abstract at the moment. So here in our plugin, so it creates a few things on disk on the device when I deploy it. So the number one thing it kind of has to do at first is it creates an operation definition. So this says, if I receive that C8Y parameter update operation from the cloud, which is the Cumulocity specific thing, what do I do? So here I'm defining when you receive this operation on this operation channel, then do this. So here I could have also done just a plain script execution, but I also wanted to kind of utilize a lot of thin-edge's powerful functionality like workflows, where workflows is you can define your own kind of state machine to define what to do at different stages of the operation that you're executing. So that could also be complex things like restart the device, which is not something, you have to kind of shut everything down, restart the device, come up and resume your operation. So it is a very complex workflow. So here we decided that we wanted to actually execute a workflow. So within the plugin, and this is where the abstraction then comes in, we actually execute saying, well, when you receive this from the cloud, translate that to a local thin-edge command, which will execute this parameter update. Now, why else would I do this apart from getting the advantages of being able to do like fancy things like resuming state if it crashes and stuff like that? So the second main reason for creating an actual workflow to do the actual work is because we've now created a cloud abstraction. So it means that if you have, your primary contact is Cumulocity for, 99% of your fleet, and then you have one bigger customer that comes along and going, we have our own cloud, can you connect to there? And then can we do parameters? Technically, yes, because the only thing that you'd have to create to abstract for a different cloud would be create a new definition for a different cloud. So it would just be mapping whatever this is coming from, I know, AWS, whatever, and then you're mapping to the same locally processed operation locally, which is cloud agnostic. So having this kind of thing encourages people to create cloud agnostic kind of plugins, because the more agnostic it is, the more uptake you're going to have for people adopting your plugin. So it means that you might get a little bit more, additional customers that you didn't think you would actually win. But all of the nice UI elements, yes, they're purely Cumulocity, so it works seamless with Cumulocity, but it doesn't preclude you from using other clouds to then, if you need, the odd customer that wants to integrate with their own cloud. So you don't need to redesign your IoT solution on your device. You can reuse the same components. So that part is a very, very powerful feature, and basically number one thing why we say, if you can, use a workflow because you get this for free. And you can also do like local execution if you really wanted to as well. Like if you have like a local UI or whatever, and you don't have to be connected to the cloud. So once I receive a operation from the cloud, it'll go, hey, this is my cloud data format. I'm actually going to translate that to a local data format. So here I'm actually just then taking the format, or like the script's taking the format of the cloud, going, okay, I'm just going to pass it on as is because I don't want to change the data model. The workflow kicks in and go, okay, cool. I'm just going to, go through, set the states so the operation transitions happen. And then I'm just going to do a preparation step. And so all of the actual work is being done by this parameter update.sh script. This is doing something with the payload, maybe doing a reformatting so it's a little bit easier to kind of like reason with. And then it's doing actually the work, like, hey, I now want to set these values. If we look at the parameter update script, we're talking 58 lines of POSIX shell script. So this is super portable, nothing to compile, and it's not too wild, so it's quite easy to test. So with this is providing all of the backbone to this kind of like orchestration logic to saying, well, how do I then coordinate this to a component that knows what to do with this data when I receive it from the cloud? So for example, like, how do I know what parameter to set? If I'm talking like, if I want to manage the flow parameter toml files, how do I know which flow it is? This is where the plugins come in. So if you see here in this kind of prepare command, we try to decipher like, what type are you? Because maybe for different types, we want to kind of like define a schema so we can decide, well, what plugin do we actually hand off the work to? So we just use a simple, split on underscore that we then can delegate to the different kind of plugins which know what to do with it. So here, if the name of the parameter being modified just starts with flow params. So if we look here, flow params, it has the association. So this is really up to you to define, like, it's just something that we decided on. So you can change this to whatever you want. It's just an example to show different ways of doing it. So we'll then hand off to this thing that actually does the work. Because in this logic, we don't really want to say, what do I do? We don't care what a thin-edge flow is. We're just basically routing data to different components that know what to do with it. So it can remain really dumb, and it's just routing logic. So the actual work being done is then we've basically created our plugin system, like a parameter plugin system, where we have a really super easy interface. So here for a flow params, we just have a set a get function, which is actually doing nothing. So it's mostly the set function that we're really interested in, to then do something when we receive the data model to do something on the device. And that parameter, what does it do on the set? So update parameters. It will then find the corresponding flow.params, the params.toml file where it actually needs to write the data. So it's actually even translating the JSON to TOML and then writing it, et cetera, et cetera. So with a simple kind of mechanism, and again, like this is 50 lines, it's quite easy. And this comes very easy if you want to, point AI and say, hey, generate this for me, or understand what it's doing. You can use all those tools to create these things because it's very easy input and output function. And so it's not complex, and AI is very good at generating all of that kind of stuff. So with that, then you get this full completion from when you set it from the cloud to setting the files on disk, and then that's automatically reloaded. And then we're publishing the value back onto the digital twin with the new updated values. And then we have that full, get or set get kind of combination. So then the UI is then informed, yes, we're now completed. They get the updated values, and then we're all good. So you can do then the next change. Might sound a little bit complicated, but once you start pulling apart the bits and get AI to explain it for you, it actually is fairly simple. All of the bits kind of like you can combine. So here we have like another like auto updater is a fictitious thing that, we can describe what it does. And then you say, well, actually on the update parameters, I want to, reset something or write to some random file or do an API call, whatever, it's up to you. So with that kind of functionality, you then get kind of this end-to-end kind of experience that you can then do other values, so you can kind of tailor make those kind of UIs, and you get all of that for free as long as you define the data model. So the reason for with one advantage of doing it in this flow params kind of style is that actually works for all params.toml files now. So it will actively, so if I install a new flow, as long as I create that digital twin manager asset definition, I will get that for free. I don't need to change my flow to say, hey, you need to also publish here now. I could have done, but it's also a powerful mechanism. So it's kind of like, I have something that knows about flows, like thin edge flows, and interpret the data from that to expose it then to the Cumulocity, so I then can edit the data. So that is quite powerful. So I don't need to write one plugin per flow instance. I can kind of generalize it. So you can adapt this to other things, whether it's just, you're writing to file or to some whatever other API calls. It's quite easy to kind of change it to. So with the plugin, you can, so it's hosted on our Cloudsmith repository. So it is because it's all kind of POSIX shell, it should be quite easy. So there's no architecture specific kind of distributions, and we're looking at, I don't know, 2 kilobytes or something, or 6 kilobytes. So very, very small, and it's more just configuration things joining up with POSIX shell scripts. So that's also a good reference for, how do I write my own abstraction system? You can kind of take some cues of this example and then customize to yourself. Also for applying it to other kind of, custom operation handlers or whatever. There's some nice useful patterns that you can reuse here. Again, utilizing AI, saying I want to do something else with a different operation. Take your cues from this, and then I think it would probably generate you a pretty good start. So maybe with the ISO, it's property definitions is the correct one, not asset definitions. So the property definitions here in the digital twin manager, you can kind of expand and see all the different ones. So you can also create new ones as you please with, just clicking stuff together, etc. Oops. So it's quite easy to kind of do, or so in some of our flows, because in our flows examples repository, we've started for some flows even just have an API request that you need to do to upload it. So it becomes quite a little bit easier to kind of manage. And you could also write this from a Git repository and then sync it and stuff like that. But at least it's quite easy to kind of facilitate. So within the repository, we've also linked to the documentation, which could be useful to kind of have a read of the kind of details of this. So there's also a little bit of explanation about the device parameters feature, a little bit more detail, and then also in the fragment library, it's now listed. So there's a few additional functionality like event changes and stuff that you can also look into and implement if you want. So I'd highly encourage reading kind of the integration just to kind of understand how does it work from Cumulocity side to have a better understanding of it. And then I believe if I linked everything correctly, the digital twin manager, you can then explore the documentation. What is that if you've never heard of it before? So it's becoming more and more used by a lot of customers because it allows you to be a little bit more flexible with defining your data models. You can control your data models, which is an important thing. So you don't have a wild west of, someone publishes a string, sometimes it's a number or all this kind of data model problems that come in. You can help normalize your data. Cool. Are there any further questions regarding parameter sets or device parameters?
Ruben, just one question. So for that schema that has to be set for all the parameters supported by the device, so that is supposed to be sent by the device itself, like the equivalent of say supported config types or supported software types in those operations.
No.
Okay.
So that's purely because it can actually be driven just through a manage object. So the actual definition is actually coming from the DTM. So you do need to have an API that can create the DTM. That does require additional permissions. It's better to check the documentation, but I think last time I checked, you need these kind of rights. And I think generally you probably wouldn't be giving this to a device user. So it's something you probably want to have part of your CI to update these definitions when you create a new flow. So exactly like what we do when we generate our flows, they're also hosted in Cumulocity. So when you publish that element, you could maybe have a property definition which also gets published when that gets published. Yeah, so it's something that the device doesn't have to publish. The device contract is just, it needs to publish the digital twin value. And also, I think the C8Y parameter, which you get when you basically do the property definition. So this will be shown in the supported operations for my device. But mostly because I have this, template set up. So when the device goes, hey, I have a parameter, it will publish this capability, and this capability then gets published or translated by the TEDge mapper C8Y to this C8Y supported operations fragment to saying, I can actually do something if you can send me this operation and I know what to do with it.
Okay.
It is possible that you get a type that it has no idea what to do with it, but then you'll just fail the operation. Going, I tried to do something, I didn't know what you meant. So that's not on a per type basis on the supported operations. It just needs that single value in the supported operations from a Cumulocity data model perspective.
One quick question. Could you share the links to the device parameter feature in the Cumulocity documentation, where it is explained in more detail?
Yes, we could look at that. Yeah. I think it's probably, maybe as reference implementations. Yeah, that could be useful.
I think the doc is not yet published publicly. Is the doc now available, Ruben?
This one?
Oh, it's available. Okay.
Yeah.
Okay.
So I think it's still being kind of like officially rolled out to all the zones. So I think that's kind of like, but we're definitely wanting people to kind of use it, you know, test the use cases, etc. So I think you can then request, and I believe like it should be in the next coming weeks. And that's probably a little bit of a conservative number. Should be then available in the different to like actively ask to get subscribed to in your tenant. But yeah, just the free kind of UI and allowing people to, because normally if you've had to define some of these things, you'd have to create your own kind of UI just to do parameters, and it's not very complex. But you know, if you do this for 5-10 things, it's an additional component that you have to maintain over time, and the maintenance cost is a nightmare in basically any software engineering. So the less you have to kind of maintain and let us maintain it for you, you definitely reap a lot of benefits from it and can free up to do actually, you know, more interesting stuff on for your business as well, rather than just doing, you know, schema-driven UIs.